Hi class, it looks like we're having some problems reading a t-table. So I decided to make this quick little video on how to be able to read a t-table after doing a t-test and getting a t-test statistic. Okay, so this is our homework from last night, that was due last night, Friday, July 19th, and I thought I'd go through the solutions here and kind of just say how I was able to obtain the p-values. So for this first example, this is actually a z-statistic. So we're going to scroll by this one and go to problem number 2. So this is a 2-sample t-test and of the lumber manufacturing company, and they would like to compare the average weight capacity of 2 types of boards they are currently manufacturing. Okay, so this is my null and my alternative hypotheses. Before I do anything, I need to calculate the test statistic. Okay, but before I can even do that, I need to do this pooled estimate. And so here's the calculation for the pooled estimate. Okay, almost there. And then I get this test statistic of -2.20. So the problem is how can I find this value from a table? Well, first I have my test statistic, but then with a t distribution, I also need to have a degrees of freedom. So in this case, I have a -2.20 and a degrees of freedom of 40. Okay, so at the end of this homework, I have attached a t-table. So let's scroll down to the t-table. Remember, I have a -220 and 2.20 and a degrees of freedom of 40. So if I scroll down to find that p-value, keep going, keep going, keep going. Okay, I have my t-table. So here I only have positive values. So I'm actually going to look at the absolute value of my t-statistic. So, but before I do that, I need to come down this column here and look for my degrees of freedom. Okay, I have 40 degrees of freedom. Great. And then I scroll across and I try to find where my test statistic is falling. Oh, there it is. 2.021. 2.423. Okay, my absolute value falls between these two values. 2.20 falls in between these. So then I can scroll up if I remember the columns. Great. Here, if it's a one-sided t-test, then it's going to be a p-value in between a 0.025 to 0.01. And if it's a two-sided test, and hypothesis that's not equal, then we'd have a p-value between 0.02 and 0.05. Okay? So that's how we read the table. Now just for, let's say we had a degrees of freedom of 9 and a test statistic of 1. Well, then we could scroll across. We have 9 degrees of freedom. Okay, I find that 1 falls in between these two values, so I'd have a two-sided p-value of in between 0.4 and 0.3, and then a one-sided p-value in between 0.2 and 0.15. Okay, so there's another question on whether or not you get this very large test statistic. So suppose I have 9 degrees of freedom, but then I have a test statistic that is greater than any value here. So it's bigger than 4.781. Then I would just record my p-value as either less than 0.001 or less than 0.005, according to whether or not it was a one-tailed or two-tailed test. Okay. So hopefully that kind of clears up how to look at the t-table. And if we scroll back up to that original problem, that 2, we can see that we had a no difference. So our p-value should be in between the 0.02 and 0.05. So right here, okay? And that is kind kind of the formula to be able to find this, but really just look up the absolute value, find where your test statistic falls given the degrees of freedom, and choose then the p-values according to those either one-tail or two-tailed p-values. It's a range of values.